actually is. Oh yeah, that's good. That's gonna work, but we're gonna get different results. So okay, that will add excitation because I don't know what's gonna come out. Okay, but now let's do it in this direction. No, let's not do it in this direction because it doesn't work. Okay, that was good. Did it go in a loop? It didn't go in a loop. It must be minus. It must be positive. Okay, that was. But now this doesn't work. Maybe it should be faster. No, it doesn't work. Okay. Let's move on to the
It's
next one.
almost closing the loop, so I guess if it was much faster then. You see now it's gonna close the loop. The middle one.
Oh, yeah.
There it goes. Yeah.
Yep.
That's not what I meant anyway. If it's fun, then that's good.
But it happened.
I mean, if you want me, what happens? What happens?
Well, the ball is closed.
So we have a video.
Huh?
Everything's alright.
Yep. Fine, I was just checking.
If you want me to do something, change something, you know, the position of the ball, and just tell me.
He's just doing the live streaming to YouTube. So.
Yeah. I mean, if you, I was talking to you, so if you want me to do something, change and stuff like that, you can just tell me. That's what I did it for. But I guess I'm gonna show you, and I'm not gonna let you calculate that.
That's
But
a very
that's
good
for this one.
illustration. That's a very good illustration.
Okay, so.
So you should put it up on the internet so people can use it.
Yeah.
That might be the way.
But change it so you don't have to recompile it every time.
Add some user interfaces.
Well, I can change Angela's speed, so it's not that bad anyway.
Or like maybe just write all of them out as separate programs.
No, I can just add.
that-
I can just add on the panel to change the or to add this ball with the mouse. It's possible. Okay. Yeah. So maybe we should see this. Now I wonder if this works. So that was meant to be the extension of this previous demonstration. So now we have not just 3 balls or just 2 balls, but like 9 balls in a row. In a row. They're small, so it's gonna look like a stick actually. And if we're lucky enough, the stick will go and rotate and let's see. Yeah. See, they just move like that, and now it probably doesn't rotate because it rotates the wrong way.
Yeah, make it go like +6 or something.
Okay.
Maybe even minus.
But then it will. Oh yeah, that's what I was thinking about. So that's okay. It just deflected in that.
Yeah,
in
make
the
it
other
plus
direction.
+3,
Plus 3.
6.
Plus 6. Yeah. Oh, that's exactly what I was talking about.
Yeah, that was the deflection point.
So does it work? It was designed so that it rotates around the middle ball.
Yeah, so it
It does.
stops at one direction and then
Mhm.
goes back. It's just like the bifurcation process.
So it's actually because.
again?
Okay. I don't know if it's exactly
That's nice.
the right speed, but if we assume that the middle one actually stops and the stick rotates around the middle ball, we can explain it by viewing it here. So now, so what happens is, it rotates when the stick passes this line, right? And it's because the middle ball just happens to move at the same speed as the points on the platform. And that's it. So that's very easy. And that's also very easy to calculate, right? But from this point of view, I wouldn't be able to do that. I would have to integrate along the path probably, the Coriolis force, no, it's perpendicular. So the centrifugal force, but it changes with R. I don't know the path. Okay, that was the stick. Now, let's see. Whoa, what did I write? Reverse omega, no rotation. Okay, if we missed that, then I hope it wasn't anything.
I mean, we
special.
started late, so if you plan on finishing soon,
Should I?
yeah. Because you have been half an hour late. and-
Okay, let's see the pendulum. So now there will be a pendulum in the middle of the platform. Yeah. But the stick. I
Oh,
suppose the stick-
leave the stick in. Oh, great.
So basically what you see is the pendulum at the
That's
North
not a
Pole.
pendulum.
Or at the South Pole actually.
This is great, Chris.
Thanks. So what you see, yeah, so it's, let's start again. And I'm gonna point at this, at this one? Yeah, so let's wait the whole period, so that will be the whole day. And we're gonna see that this thing actually returns to the same position after 24 hours. Actually, it returned already, but it wasn't the symbol. So, we're approaching midnight. And there it is. And it's again in display. So that was the Foucault pendulum. Now let's see what happens if you displace it. If sometimes it's going to be oscillate around here. I don't know if it has any significance. I don't know if you can compare it to the pendulum in London or somewhere in between the North Pole and the equator. Now let's see, because it's this fun. So now, in the rotating frame, we see kind of least Least curves, but like polar analog of that.
Ah, that's interesting. Could you make it retain the pattern, like, so that you
Yes,
would be able to
okay.
see the path?
So let's see, because now it oscillates with frequency like 30. Yes, 30. So we can make it. We can, if we set angular speed to minus 30 or plus 30, it should. Let's see. It should do one oscillation within one rotation of the platform. Okay. Does it do it? Yes, it does. So this bigger oscillation is the one which is upstream. So it's when it's now. But this one is downstream because it goes against the platform. So this is downstream and this is upstream. So let's see if it's 15. That should, so now if I set it to 15, it should have, this whole pattern would have twice as big period. It would take 2 rotations of the platform for it to return to the initial configuration. Oh, actually 30 is, okay, yeah, there you go.
Wow.
Upstream, downstream, upstream, downstream. Okay. Actually 30 is a multiple of 3, so you can also do 10. And let's see.
Did you sleep this week?
No, it took me like 3 hours to write it. I just,
Did you what? What did you have?
it took me 3 hours to write it because I'm just
Just 3 hours.
it's easy, you know. It's if I know how to use this library. It looks hard if you don't know it, but it's not hard at all. Okay, let's see 3 and let's finish this illustration. So it's basically the same pattern. But now it has like 3. You know what I mean?
Can you make it leave the trace so that you'll be able to see where
I
it
can,
went?
but that's if you're comfortable with the fact that these red guys will leave a trace too, and these green ones, then
Yeah.
I can do it. Okay. It's just here. I should. Which one? Rose and black. Oh yeah, this one was on black. So I should come in there. Oh, I should.
That was
Let's
nice.
get rid of the stick. Okay.
Oh.
I could also make the ball smaller.
Yeah.
Where's the ball? Oh, it's here. So let's say like 2. It'll be very small. That will be 1 pixel. Or 2 pixels. Okay.
That's good for these curves. It actually shows you where does it accelerate and where does it stop as well. And it's a proper recession curve.